Well, hello, everybody. Um, my name is Lawrence McAlpin. I'm an architect in the Enterprise Messaging Platform team. And with me is Alex Warshawski, is a principal engineer, also in the Enterprise Messaging Platform team at Salesforce. And we're here to talk about platform events. Before we begin, our lawyers would like you to know that during the course of this session, I may speak about some features that we plan to implement, some things that we'd like to do. Don't make any purchasing decisions based on that. Only make them based on commercially available products. The fact is that sometimes we change our minds. Things don't work out like we plan. That's me. That's Alex. And okay, so one of the principal issues facing IT today is the need to integrate multiple data sources, multiple systems. And you have customers using many different interfaces. They're using mobile apps, they're using web browsers, desktop apps. You got IoT and other machine-to-machine interactions. And you got data in our cloud, other clouds within your own corporate firewall. And you need to integrate all of that and tie them all together. All these point-to-point interactions become pretty unwieldy. Now, 20-something odd years ago, I graduated from college and I went to a small manufacturing company in the Midwest that makes big yellow earth-moving equipment. And we didn't have to make these kinds of decisions. I wrote a COBOL transaction and it ran on the mainframe. The data came from the mainframe. Our users filled out a form and hit enter, connected on a dumb terminal connected to that mainframe. But nowadays, you have to tie in all kinds of components that are living in all sorts of places, and it can quickly become unwieldy. All these point-to-point interactions become hard to manage. So we think platform events, a feature that we've introduced, provides a better way. It simplifies your integrations, your Apex code, your mobile apps, standalone apps, something in Heroku. They can all publish to this shared event bus, and they can all subscribe to the events in near real time in any of these environments. So one of the advantages of the event bus is that we provide a ubiquitous communication channel. So you have this loose coupling between the components. When you add a new event producer, nothing that was already in part of your orchestration needs to know about that. You can add new subscribers, and no one needs to know about that. Another advantage of this approach is that we offer some durability. If a component goes down and then comes back up and it missed an event, then it'll end up having a mendacious view of the world, and that could be a problem. So we provide you the mechanism to resubscribe from whatever you want inside a sliding window. So that way it never misses an event. And lastly, we support polyglottal enterprises. You have Objective-C for your mobile apps. You have Ruby and Node.js for your web apps. You have Java, you have Apex. It doesn't matter. They all integrate together using the event bus because you're communicating using open standards. You're publishing using HTTP, using SOAP and REST APIs. And you're subscribing using the Bayou protocol. So platform events are basically just a new kind of object. You're already familiar with many of our objects. We have standard objects like lead and user, custom objects, external objects. So the event object is a new class of object. It differs in a few fundamental ways, though. These are write-only objects. You can only publish them, and then you can receive notifications when they come in. You can't query them. You can't use SOCL. You can't view it on the UI. You can only emit them and receive notifications. We didn't want to create a new parallel set of APIs. We wanted to keep things simple and keep things built on the technologies you're already familiar with. So you publish using existing platform features like Apex, SOAP and REST API, Process Builder. And then you consume them externally using our durable streaming API, which some of you are probably already familiar with if you use push topics or generic messages. And you can subscribe to those from web browsers or any external system. And then you can consume events on platform using Apex Trigger and Process Builder. So one of the fundamental differences between this and a record-centric standard or custom object is that instead of publishing or instead of creating the record in a database, we are publishing the event into a sliding window. And this sliding window is currently about a day's in length, though, and this is a forward-looking statement. In the future, we may offer additional licenses or options to increase that window. Your publishers add the events in time order at the tip of the window. So you're guaranteed that you will get your events in the order that we received them. And your consumers can start reading anywhere in that sliding window. So that's how we offer that durability. If you go down for maintenance or a crash, all you have to do is remember the last event you saw, and then we'll fill you in on what you missed. So there's several types of event objects, just like there's several types of objects. We have standard events. You might be using some right now and not realize it, like asset token. And in the future, we plan to offer additional features that will emit events, like, and this is forward-looking statement, but we might publish events when you have login failures or other kind of security events. One of the features I'm very excited about is a change event. So our change data capture team is building a feature that will emit events whenever you create, update, or delete a supported record. And you can react to that event in near real time. There's a session on Wednesday where you can learn more detail about that. That's called Synchronized Data to Postgres with Change Data Capture. The exciting thing about that is, unlike a trigger, you can subscribe to these things off-platform, so you can keep things in sync across your enterprise. And currently, earlier this year, we released custom platform events, which we'll go into in more detail. Custom platform event is a bit like a custom object. You define your metadata in a setup UI. One of the differences is that it has an __e suffix in the API name. And then we have a standard field. Here, I'm going to drive.
Escape.
OK. And so you can see here the API name has the __e suffix. We have a standard fields on it, just like you have for objects, but instead of an ID, we have the replay ID field. This is an opaque identifier that you can hold on to. So when you see this event, you give it back to us when you subscribe, and that's where you would start your subscription from. And then you can add custom fields, and you can attach triggers and process builder in the manner that you're already familiar. And also, we support packaging, and you can use like profiles and perm sets to control who can publish and subscribe. So publishing, like I said earlier, you can do through API, process builder. The Apex interface is a little bit different. Instead of a database method, which doesn't make sense because we're not writing to a database, we have an event bus publish method. And one of the main differences here, though, is unlike a database insert, this is non-transactional. If your Apex transaction rolls back, your events still got published. So you'll have to accommodate that in your design. And also, we do not throw a DML exception if you try to publish a batch of events, and one of them has a field validation error. The other events will still go through. The one with a field validation error will just end up in the save result, and we'll tell you why we didn't publish it. So we do not support all or nothing. It's whatever works, publishes, and it's non-transactional. You can't roll it back. And then your triggers, there's some slight differences. We only support after insert triggers in an event object. We support in-order execution, one batch at a time, so we guarantee that you will not receive these events concurrently on, two instances of an Apex execution. You can guarantee that you will process your events in the order that they were published. Unlike standard triggers, which cap out at about 200, we do allow more to around 2,000. Events are typically very small. You just want to describe a thing that happened and not like pack in all the data about the thing that exists. So because they're smaller, or they're supposed to be smaller, we can allow you to receive larger batches of them. And they run as automated process user, which is a special user that we have in all orgs. In the future, this is another forward-looking statement, we plan to allow you to customize some of these settings, so you can limit the batch sizes, or maybe allow concurrent execution or run as another user. But these are the defaults that we went with right now. Subscribing externally is done through our Durable Streaming API. That's pretty well documented online. It uses the open standard Bayou protocol. Common D library is a popular implementation of it. And I think Alex has a demo which would probably illustrate that a little more clearly.
Okay. All right, so at this point, I would like to show you platform events in action. I have two parts to this. I have the publishing end and receiving end. So on the receiving end, there is a Lightning component that subscribes to Event Bus. And on the sending end of this, I have a Heroku app where customer can submit order feedback. There are two pieces of information that come over, as you might have seen from the event structure before. One is there's an order number, and another one is description. So what happens here is randomly generated order feedbacks. So customer saying, I have order 51 and I would like to return it. And let's send another one. Okay. And that doesn't happen. So one way to publish events is through JavaScript, and I will show you the details of that in a minute. And you can also do it using REST API. So there is another. It just took a while for this order to come through. There's another order feedback saying order 49 is a happy order and customer doesn't want to return it. It will be important in a minute. In this case, I'm using REST API. There's a REST API endpoint /s/objects customer request, and I'm sending order number, workbench 777, and then there is a description, return this order please. When I send this order, it comes through as well, and these notifications come up. And what happens as a result of those orders, you can see order 49, 51, and WB 777. And when I refresh this list of cases, you will see that there is order 51 case created, and then there is WB 777. And order 49 doesn't have a case associated with it because it didn't have the word return in it. Because customer is happy with it, we don't have any case associated with that. What happens behind the scene in this app? On the sending end, there is some JavaScript where REST API endpoint is being used, customer request E, that's the object, that's the event object, and I'm simply generating a random number between 1 and 100, and then if order number is greater than 50, I'm returning an order, otherwise I'm happy. This is only as a this is for the demo. In real life, you would probably have a form and you would type up order feedback. And then on the receiving end, what we have is we have a Lightning component, and the code inside of this Lightning component is subscribing to events using commit-d library. So there is commit-d library here. Its commit-d URL is pointing back to Salesforce to use the streaming API. And then there's a helper that's processing events as they come in. So there is a subscription, and then this is the channel, and as events come in, something happens, right? And if you look at this, we're receiving events, and then display toast is the notification widget that you saw on the bottom, where order number is displayed with a description. Now, what happens and how do these cases get created? Well, we have this trigger on the event. As Lawrence mentioned, it's an after insert trigger, which is the only trigger supported now for events. And as these events are being processed, you can see this loop here, which is very familiar for anyone who wrote an Apex trigger before. And then we look for the word return in the description. This is why when there was word return in the description, there were cases created. And when we see that, we know that customer wants to return an order. We automatically create a case. We just say process returned for order number, and order number is captured, and then customer feedback is still there in the description of the case. This is, so what I've shown you as part of the demo is one way to test those triggers, right? You see the cases being created in the UI. But triggers could be much more complicated and would need a lot more logic to be tested. How would you do that? What you can do is you can write a test class. Let me show you, it's right here. It's an Apex class, and what's special about it is you have isTest annotation on it, making it a test class. And second thing is there's a very important block of code here. When you publish events between test.startTest and test.stopTest, those events are published only for testing and do not affect event bus in your org. And you can publish up to 500 of them for the testing purposes. So what this class does, it verifies that for the order number that we're testing with, we have 0 cases before we start, before we publish events. Then event is being populated, and then event is being published. And then inside the test, we see what happens as part of that. We query the cases, and we see that there's one case that came back, and we expect customer feedback in the description. So we see what happened as a result of that trigger. Now, these events change over time just like any custom object. You can see that there's a couple of fields here, description, order number, but as we know, things change in business and you might want to capture other information here. And just for demonstration purposes, what I wanted to show you is there is something that we do to show you the structure of the event over time. And that is event schema. If you look at the events coming through the wire, and I can subscribe here, when I publish this event, for example, using this, that event will show up as part of the stream. And you can see that it has a couple of standard fields and a couple of custom fields, order number and description. As part of that, there's a special string called schema. There's a field on there in JSON. And that allows you to look up schema of that event with that payload at that time, right? That's the schema at that point. And if I take that string there, there's a REST API endpoint /event schema, and you can look up what schema look like at that point, right? With that ID. Now, what happens when I add another field? So let's say I'm adding a number field, and we can just call it number. So there's a new field here on the event, as you can see. Now, when I publish this again, and you look at what happens on the wire, there's another field here. Since we didn't fill out any values, it will be null, but this is now part of the schema. And you can see that the schema ID has changed. And now this new schema is part of the event payload, and that's the event structure.
Can I interject? I'd like to also point out that when you subscribe, there's an option to get the payload in a binary, more compact format. The messages are actually Avro encoded, so if you have Avro, it's supported by most major library or most major languages. The library is available widely. You can use that to deserialize your events.
Thank you. And part of that evolution of the schema is that you can still look at the old schema because events might be still in the stream with the old schema, right? So you can introspect that older schema using this API, and you can see that it still has 4 fields in it. So when you validate that event, for example, against the fields that it's supposed to have, you can look at the schema and see what fields are supposed to be there at that time. So as event payload goes out, it has schema attached to it. So there's some things you can do on your own. Let me show you this. We have a couple of Trailhead modules. One is called Platform Event Basics. That's where you learn about defining events, learning about triggers. There is another Trailhead module which is a little bit more advanced, which is called Build an Instant Notification App. And that was the basis for big parts of my demo, that you can play with that as well. And of course, we have online help, part of Platform Events Developers Guide. Thank you. Do we have time for questions? Okay, we have a little bit of time. Any questions? Go ahead. Do we have a microphone?
The limits platform events in terms of how much you can fire. I mean, that'll vary based on your edition, and also there's additional licensing options to increase it. Do you remember offhand what they are? It's like 100,000 a day, I think, as a base level. No, it's fired in the context of an org, and that org, it'll apply to that org, their limits.
Yeah.
You have a question? Up to 2,000. It won't always get 2,000. It's kicked off, and just we wait a little while, and then we'll. Yeah.
What I'm wondering about is,
Maybe you should turn off the microphone, and we can just answer questions. Can we?